The Science Success Center, with funding from Title V, presents Astronomy Workshop, chapters 11 through 15 of the book ASTRO by Seeds. Hello, I'm Julia. Einstein's special theory of relativity applies when traveling near the speed of light, which is debatably quick. Time slows down when objects move quickly, and it's different to each observer. Time is relative, so it depends on where you are. The faster you move, the slower time moves. Next, mass appears to increase. If an object is moving at a high speed relative to you, the object will appear strangely. Its mass will increase so that it becomes harder and harder to accelerate as it approaches the speed of light. Then, length contracts or decreases. It will appear to shrink in its direction of motion, becoming more and more distorted as it travels faster. Spaghettification is the concept that the force of gravity is greater on the astronaut's feet than on his head. This difference will lengthen him, eventually pulling him apart. These effects happen to every object, but they become noticeable once objects approach the speed of light. In Einstein's general theory of relativity, gravitational time dilation explains how gravity affects the rate of time. A person on a high spot of a mountain will have a faster time on their clock than the person closer to the floor. Clocks run slower in regions of lower gravitational potential. Gravitational lensing describes how rays of light bend in a gravitational field. The presence of matter can curve space-time, and the path of a light ray will be deflected as a result. Gravitational redshift occurs as photons travel away through space-time. Furthermore, the universe expands quicker than the speed of light. Cosmic microwave background radiation, CMBR, and the COBE satellite. Arno Penzias and Robert Wilson discovered cosmic microwave background radiation in 1964 due to the findings of work by Gamow and Dickey's radiometer and hypothesis. Why? Because it explains radiation left from the Big Bang Theory. COBE explains the radiation left by the Big Bang Theory, and it's not to be confused with Kobe, the basketball player. But what this satellite did is it took pictures to explain the jumpiness of the microwave background radiation. Here are three models of the shapes of space and time. In the open model, space and time expand forever to infinity. There is a negative curvature and it is saddle-shaped. In the flat model, space and time expand forever to a limit, but not to the critical density. It is flat. Finally, in the closed model, there is a collapse and a positive curvature is formed. It is arched. The universe is closed, use the rainbow. Just kidding. Steady state theory. In the steady state theory, new particles are formed to fill in the space of the expanding galaxy, and the universe looks the same daily. In the Big Bang theory, Hubble discovered the redshift is proportional to its distance. This means there was an initial high density and high temperature state. Galaxies move and recede from each other since they have no center. CMBR is spread over the entire sky, and that is the evidence for this theory. Here is a depiction of the Big Bang Theory. In 10 to the power of negative 43 seconds, there was an initial high temperature and inflation state. In practically what it takes to blink your eyes, particles were forming at 10 to the power of negative 10 seconds. Next, protons, neutrons, and helium nuclei developed along with the proton-proton chain by 3 minutes. Following this, atoms and plasma were formed over 300,000 years. Stars and galaxies took 1 billion years to form, and now humans observe the cosmos almost 15 billion years later. there is a difference between dark energy and dark matter. The Pokemon Mewtwo might use dark energy, and the Transformer Megatron might use his dark matter beam. Well, who will have more to work with? What we can account for in the universe, 74% dark energy repels, 21% dark matter attracts, and approximately 5% bright matter. This explains why the universe is expanding out of control at an accelerated rate, the cosmological constant, the quintessence or new force, and a possible outcome of a big rip or a big crunch. In addition to why Mewtwo would win with his dark energy by a landslide. When it comes to the formation of a solar system, if you look at A and B, it shows the solar nebula contracts and flattens into a spinning disk. The large blob in the center will become the Sun. Smaller blobs in the outer regions may become jovial planets. Picture C shows how dust grains act as a condensation nuclei, forming clumps of matter that collide, stick together, and grow into moon-sized planetesimals. Picture D illustrates strong winds from the still-forming Sun, expelling the nebular gas. Then E displays the planetesimals as they continue to collide and grow. Finally, F relates how over the course of 100 million years or so, planetesimals form a few large planets that travel in roughly circular orbits. Here is a breathtaking view of the planets of the solar system. Terrestrial versus jovial planets. These are the two different kinds of planets that we have. Terrestrial planets are formed slowly from accretion disks. They're high density. The inner four planets, smaller, rocky, have no rings and few moons. On the other hand, jovial planets are formed by gravitational collapse. They're low density. They're the outer four planets, larger, gaseous. They have ring systems and lots of moons. Now for Earth's structure. Our Earth is covered in a dense crust, and beneath it is a mantle. As we get closer to the inner Earth, we have the liquid outer core and a solid inner core. The composition of Earth's core is mainly iron and nickel. About the Earth. Global warming is caused by an excessive amount of carbon dioxide concentration, which in turn causes a greenhouse effect and the temperature rising. Polar ice caps melt, and in turn, coastal cities flood, leading to endangerment of certain species. Differentiation is the separation of material by density. For example, the many layers of the crust for the Earth separate it depending on how dense they are. The ozone layer. Ozone layer depletion is caused by man-made chlorofluorocarbons, CFCs, which cause the increase of UV rays we receive and cause more cases of skin cancer and genetic mutations. Proof of continental drift was found by Wegener, who discovered it through rock specimen similarities. The Glomar Challenger mapped the ridges of Earth and also found samples of the core that showed seafloor spreading. On our journey through the solar system, we become a sailor to the moon, just like Sailor Moon without the superpowers and great haircut. How is the moon created? There's the fission hypothesis, in which the moon broke off from rapidly spinning proto-Earth. There's the condensation hypothesis, where moon and Earth condensed from the same cloud of matter. And there's the large impact hypothesis, a planetesimal smashed into proto-Earth, then ejected debris into a disk around Earth where it formed the moon.